Welcome to Key Skill 3. In Key Skill 3, we're going to be going in the opposite direction. We're going to be going from polar back to rectangular or Cartesian form. And actually, it's a little bit easier. So that's my secret. So we're going to start with 2 kiss 60 and we need to go back to a rectangular form. So we're just going to expand this out a little bit. Okay, now here are your exact values. So cos 60, let me think about my triangle. 60, 30, 2, 1, square root 3. So cos 60 is going to be a half. And sine 60 is going to be square root 3 over 2. I expand with my 2, so I get 1 plus I times square root 3. And it's that simple. Let's have a look at another one. Now we're going to pick an example that is in radians. Now we have 3 cos pi over 4 at I sine pi over 4. Again, some more exact values that you need to know. These ones are coming from the 1, 1 square root 2 triangle, where if that's 90 or pi over 2, these have to be 45 each or pi over 4. So that's going to be square root 2 over 2. If I rationalize, because if this is 45, cos 45 is equal to 1 over square root 2. But don't forget, you have to rationalize, which leaves you with square root 2 over 2. And all you need to do now is expand this out. So you would have 3 square root 2 over 2 plus I 3 square root 2 over 2. So this is the rectangular form and this is the polar form. Now, so far I've been being nice. I've given you all region 1 examples. But let's have a look at what you would do if you had an example in a different region. Now, 150 degrees is going to be in region 2. It's going to be less than 180 but more than 90. So this is region 1, this is region 2. So we're going to start with 4 cos 150 at I sine 150. And it all links back beautifully to what I taught you about the unit circle and the different regions. So we're going to calculate this acute angle here. This one has to be 30 because these guys are on a straight line. They need to add up to 180. So 180 minus 150 is 30 degrees. Now here, all sine, tan, cos. We're in the region where sine is positive. So cos here, and you can see obviously over here is left of 0. This is going to be the same as minus cos 30. But the sine will have the same sign as sine 30. Now back to those exact values. For 30, cos is going to be adjacent divided by hypotenuse, and sine is going to be opposite. So cos 30 is going to be square root 3 over 2, and sine 30 is going to be a half. Don't forget your minus. Times by a half. Expand with the 4. So that's going to give you minus 2 square root 2 plus 2i. So working other regions is pretty simple. You work out the acute angle, but just pay really close attention to the sign. That's where they're going to catch you out. This one's a bit more of a fancy proof style question, but it's not too tricky actually. If we consider what z star means, it means the complex conjugate. So if z is equal to x plus iy, z star is equal to x minus iy. So if you think about z could be up here, for example, x plus iy, if we assume that x and y are both positive, but minus y would be a reflection here in the real axis here. But minus y would be a reflection here in the real axis. So instead of going up, you would go down or vice versa. So how would that affect the polar coordinate? Well, in this case here, that would be theta, and now we would have the reflection So it would be minus theta. So the modulus will be exactly the same. The length of the line is not changed, it's a reflection. But Z star would be equal to R cis minus theta. Okay? In the next video, we're going to be looking at the proof of how we can multiply two numbers that are in polar form. Like, what is the rule for doing that? What is the formula for doing that? And where did it come from? It's really interesting. I see you guys in the next video. I hope you found this helpful. Leave me a comment below. I love to hear from you guys. Bye for now.